Morning. We are on lesson 12.4, problem 2, page 693. And by the way, it looks like we're postponing the test and review until after spring break. We'll finish off chapter 12 and finish off stats projects and then review when we come back. You'll need a review and one of these little guides, a protractor. You can get what we're doing by looking at what we do, but if you have one of these, pause for a minute and then you'll be able to use it with us. Do we have those guys turned on, Martine? All right, my friends, here we go.
Let's get on our math go.
The line segment shown, Andy, represents parking spaces in a truck parking lot. One grid square represents 1 square meter. So parking lot, back to the parking lot. Using a protractor to determine the measures of angle V, UW, XWY, and ZYW, what similarity do you notice about the angles? Now again, how an angle works. There's a symbol for it, V, U, W, and the way angle notice or notation works is that U, or whatever you see in the middle of the 3 letters, is the vertex. So we'll go like this, V, U, W. Now it looks in my eyeballs like 90 degrees, but we're going to use a protractor to verify it. The way a protractor works is there's a little spot right here where you can see a hole usually. Okay, that goes on the vertex, and then you can adjust and turn it. Now there's also a line along the bottom. So the first thing you do is line up the vertex and line up the bottom line on one of the rays of the angle. Okay, there. That looks pretty good. And so I've lined up this bottom line along the bottom ray, and then I look up the other ray, and what do we see? Looks like 90 degrees to me, yes? Okay, so now that was one angle, so this angle I've verified with my protractor is 90 degrees. Now I'll come down and I'll put the vertex on W. And again, on the compass or on the protractor, the vertex has a little hole. I will slide it along so that the bottom line is on one of the 2 rays. And then I look up the other ray and look out to the edge. I extend it with my eyeballs out to the edge. What do we see again? 90 degrees here. And then the last one was ZYW. Here's ZYW. So this angle right there. Again, let's see. Notice on these protractors too, there's a 0 on both sides. So I can measure from this side up, and I'm looking at the top numbers along the protractor. Here's a 0, and then I'm looking at the bottom numbers along this arc. Okay?
Yep.
Got it? So now, here we go, vertex at point Y, and then slide it up so the bottom line I'm using right along here again. And so now I'm looking, wait, no, I'm gonna move over here all the way up, and once again it looks like things are 90 degrees, 90 degrees. Are you seeing the same thing I'm seeing?
Yes.
Okay, what similarity do you notice about the angles?
All 90 degrees.
All 90 degrees. Two, carefully extend UY to create line P. UY? That looks like a V. Oh, here's UI. UI is right here. So we're going to extend UI. And we're going to call that line P. Extend UV. Here's UV. That was the one I was looking at the beginning. What we have right now shown is a segment. They're changing it up and extending to create lines. This is going to be line Q. Extend WX. Here's WX to create line R, and UYZ to create line S. So a couple more lines. WX was going to be R, and YZ is going to be line S. You got that? You're ahead of me? Determine whether the lines given are perpendicular or parallel. We talked about parallel yesterday. Parallel looks like train tracks. They go forever and never touch. This girl down here is reminding you what perpendicular is. Okay? Somebody to read this speech bubble for me. Thank you, Jerry.
When lines or line segments intersect at right angles, the lines or line segments are perpendicular. The
Okay.
symbol for perpendicular is whatever that thing is. Upside down to you.
Yes. Okay, so Q, R, and S. Q, R, and S. Find those lines. What should we call them?
Parallel.
Because Q, R, and S are these lines, and we just verified those are all going at the same angle. So P and Q. Here's P and here's Q. Christopher Bernal, what do I call these? Parallel or perpendicular? Okay, well this, and this is parallel. So how about these two? Are those parallel? What? Perpendicular. First of all, he could tell something different was going on, but what did we just say, Kenya, was the definition of perpendicular?
Perpendicular is where the lines meet.
Meet at right angles. What's right angles?
90 degrees.
90 degrees. So we just measured this as 90 degrees. P and R. Here's P, here's R. These two lines. These two lines. Perpendicular again.
Can't you just write the symbol?
Sure. And P and S. Chris V, what do you think about P and S? Perpendicular. Okay, flip the page. Predict how the slopes of the lines will compare. Do not actually calculate the slopes. Predict. What did we hear yesterday about parallel lines?
They're all the same.
So just a reminder, parallel from yesterday have the same slope. What do you think is going to be true about perpendicular? What do you think is going to be true about perpendicular? 30 seconds at your tables. Ready, go. Okay, good. Talking.
Or they all meet at a
Talking.
This could be what?
Okay, they look like this. What's that going to do with the slope? Here is identical. What do you think?
Like me and what?
Good, but what about the slope?
I know.
This line has a slope, and this line has a slope. Is there going to be any relationship? So if one was 2, the other could just be 8. No relationship over like here, if one was 2, the other's 2.
No, I'm not doing this piece.
Did you guys get something? Write it down. Number 4. This is a prediction. You may be right, you may be wrong. Okay, you guys got something. Okay, that's the angle, but the slope. Remember, if this is -5, this one's -5. That's yesterday. So if this is -5, what's this one going to be? Okay, that's a prediction. Maybe they are the same value but opposite numbers, like opposite sides. That's a prediction.
Maybe it'll rain.
Okay. I don't see anything written down. You guys got an idea?
Alright, mine looks
You
better.
guys got yours written down? Commit. On paper.
Maybe they
Say. This is 2. This is 2. But if this is 2, this is. It can't also be 2. This one's 2. So he's saying 4. So it's a multiple. So there's some sort of relationship. Oh, you look back. You look at those kids. They look nice on you, but that'll hurt your eyes. Okay. What do we have for some predictions around the room? Yes, Jerry.
The slopes will be different.
Different. Okay, that's a general prediction. Okay. What else? In what way will they be different?
Unrelated.
Okay, maybe there's something like positive and negative. Positive, negative. So there might be something different in positive, negative in terms of the slope. Anything else?
Exactly the same.
You think they're going to be exactly the same as a prediction.
Yeah.
Okay. Now, using the graph and the lines you drew, determine the slopes of all these lines. So let's flip back. Okay. Let's do line V first. And I think one of the easiest things to do is We have 2 dots that are exactly on the grid. We could find others, or we could look at this. Start on U. Put your pencil on U.
You.
Count up. How many boxes do you have to go up to get the level of V?
10.
10. So if we're looking at, for line Q, rise over run, we're starting off with 10. Now from here, how do we...
5.
1, 2, 3, 4, 5. Okay, what's 10 over 5? What does that reduce? Okay, so next to line Q, I'm going to put M equals 2. That's what the slope is. Now, let's do the same thing with W. Start at the W, go up to the level of X. Mr. Bernal, how many boxes is that? Look on your graph. I just counted them. I've got to count. Anna, did you count them? What'd you get? She got 10. And then we got to go from here. How many boxes over? We're doing rise over run. 1, 2, 3, 4, 5.
5 and 10.
Okay, again. So line R, M equals 2. What do you notice? Okay, and line S, what's line S going to be? M equals 2. Okay, that is yesterday's lesson. We already knew the parking parallel. Okay, slopes are the same. Here's where the thing comes in new today. Start on U. Put your pen on U. This time we're going to go down to the level of W. 1, 2. Okay, so wait a minute. Down is -2. Okay, so 1, 2 down. How many do we have to go over to get to W? 1,
6.
2, 3, 4. Okay, that reduces. What is that when we reduce it? Negative 1/2. Okay, so line P, M equals -1/2. Okay, so that's what they wanted us to do with it. I'm going to flip back to make sure I see what... Here, oh, I've got it in 2 places. What our next question was. We are on... No. 5. Use a graph you drew and determine the slopes of lines P, Q, R, and S. Okay, let's go ahead and flip that on back. Line P, line Q, R, S, all are 2. Determine the product. What's product mean? Multiply. What do I have to do with that 2 to be able to multiply? Product is when we multiply. What's going to happen with these 2's? Cross cancel, right?
Yes, cross cancel is the key.
Do you like that, or you want me to reduce after?
Cross cancel.
Cross cancel, divide, that goes in once, that goes in once. -1 times +1. +1 times +1. That's -1. The product of the parallel lines is -1. Determine the difference between the slopes of the 2 parallel lines and the slopes of the perpendicular. Put a line down the middle of number 7. Here's parallel. The lines that are parallel are line Q, line R, line S, and its slope is 2, 2, and 2. What's the difference?
Name.
So how about, is there any difference in the slope?
No.
No difference in slope. Here's perpendicular. Line P is -1/2, and line Q is 2. Okay, now one group predicted, or I heard around the room a little bit, there might be a positive and negative. Do we see that? Okay, so yes, they are different signs. One's positive, one's negative. What else do you notice? One group said, I think if one's 2, maybe the other will be 4, or there'll be some sort of relationship there. There is some sort of a relationship, but is it a multiple? What do you notice about 1/2 and 2? They're kind of the same, but how are they different? What's the same? What's different? We got the plus minus already. How does 1/2?
That one's like negative.
Okay, let's, I think you need to talk at your table, because right now Jerry and I are talking and the rest are waiting for Jerry to come up with something they can write down. So turn to the 4 people at your table. Your key question here is right there. What is going on with 1/2 and 2? How can we describe that in words? Talk to the people at your table. 1 minute starting now.
They are the